congruence first. We have seen some of the objects like stamps and biscuits and coins which are similar to each other, like 1 rupee coins we take which are similar, having the same stamp on both the sides, or for each one, for each side, comparing coins, so which are having similarities. So this kind of things we'll call as sum of with some name, that is congruence, because we take one of the stamp and we keep over on it, and then we can understand that what is the picture is there on that stamp, first stamp, the second stamp, it is same, and the shape of the stamp is also same. So the objects which are having the same size and same shape and same as it is, and they are present, which is copy of another, and then we call them congruence. They're congruous to each other. Like if we take the coins, if we take 1 rupee coin, and on one side, like if we take head and tail on both the sides with the same picture, and we take the 2 coins, we keep one and another, one on another. Then when we look at them, and they are equal in shape, and also they are looking same with the shape and size also along with the picture, and we call this kind of objects are congruence. So this is the congruency of the pictures. So any diagram if you take, congruency figures we call, like for example we take any picture like any objects like circle which is having the same shape and same size, we call them congruence figure. And similarly we take for similar triangle, rectangle and so many figures for them, and we take for irregular objects also, and then here plane figure. For the plane figure, if you take any objects like which is like diamond shape, so let us think that these both are equal in size and shape, then we call them these 2 plane figures are congruous to each other, they are similar, then we call them they are congruous to each other. And line segments, coming to the next point, line segments. So if the 2 line segments are equal in length, we call them they are equal in length, then we call them congruence. They are congruous to each other. The line segments are congruous to each other. For example, if we take one of the line segment AB is 5 centimeters, AB with 5 centimeters, and then CD is also 5 centimeters, and then we call AB is equals to, AB is congruous to CD, because we know that we have discussed in earlier classes about the congruency. Congruency, symbol for congruency is that we write equal to and write some sleeping S on the top of it. So this is the symbol for congruence. So congruency symbol, we take the 2 objects and we write between them like AB and CD. They're congruous to each other, and then AB is congruent to CD. So AB is 5 and CD is also 5. So in this manner, if 2 line segments are equal in length, we call them they are equal. So they are congruous to each other. We take the angles. If one of the angle is 30 degrees, angle AOB is 30 degrees, and angle DOC is also 30 degrees. DOC is also 30 degrees. Then we call angle AOB is congruent to angle DOC, because the 2 angles are equal to each other. Like angle AOB and angle DOC, they are equal to each other. So 30 degrees and 30 degrees, they both are equal, and then we call them they are congruous to each other. 2 angles are congruent to each other, and this is the congruency of angles. Let's go to the triangle. when we compare the two triangles, like if we take one of the triangle is triangle ABC, and triangle PQR, triangle PQR, in this, the corresponding parts of the triangle are equal and corresponding angles are equal, and then we say that two triangles are congruent to each other. Like if we take AB, as one side in a triangle, and then AB is equals to PQ. Like if it is 5 centimeters, then PQ should be 5 centimeters, and AC is 3 centimeters, and PQ also 3 centimeters, because we have discussed the corresponding parts of the triangle are equal. So when we have taken it, then we consider the two triangles and we compare two triangles, like their corresponding sides. We have discussed about the corresponding sides or corresponding parts of the transversal or corresponding sides or corresponding angles at the same side. And what is interior, another is exterior, same line. So they're the same side of transversal. This is parallel lines, and one side, on one is in the same side they are present, the same side they are present. So they are called as corresponding sides. So and AC, when we see AC at the same side they are present. So AC and PR, they are equal. And in this manner we call them corresponding sides, and corresponding angles are angle A, angle B, because at the same side of the line is the upper part of that, and base is PQ and QR. When this corresponding side A is it's looking same, so at the same side of transversal is formed, when the parallel lines are attached, like AB and PQ are parallel lines, with the AC and P are parallel lines, at the same side they are formed. So angle A is equal to angle P. And coming to the sides, here BC, QR at the same side of line. So at the same side they are present. If we take 4 centimeters, this is also 4 centimeters. So we get those corresponding parts must be seen. Like we take the angle B, it's equal to angle Q, and angle C is equal to angle R. In this manner we can compare, when we compare these two triangles, the corresponding sides are equal and corresponding angles are equal, and then we say that they are congruent to each other, and the two triangles are congruent to each other. Like if we see triangle ABC is congruent to triangle PQR, we write in this manner, the corresponding parts of the triangles are equal. And then up to now we have discussed about the congruency. Like if you take the two pictures which are same, we have taken two figures which are similar, like the same size and same shape, and with the pictures which are present on that also same. And if we have taken the stamps, we can look at the stamps which are the same, like 5 rupee stamp, the picture, same picture, we have taken 5 rupee stamp and the same picture, and we keep over on it each other, and then we get the same, it fits to each other. So when we compare it, is just it's same as it is, with the same size and same shape along with this picture. And this kind of things we'll call as figures or objects are called as congruence pictures. And figures, if we take them in figures, when we compare them, the corresponding parts are equal, the same size and same shape. We call plane figures are equal, and line segments, coming to line segments, they're equal in length, then we call them congruence to each other. The line segments are congruent to each other. And angles, they must be equal. One of the angles must be equal to some other angle, then we call them they are congruent to each other. Congruency of angles. Triangles, the corresponding parts must be equal, corresponding angles must be equal, and we call them triangles are congruent to each other. And these are the concept. This is the concept about the congruence. Let us go to the triangles and its different types of congruency rules and different criteria rules about the congruency of triangles. Up to now we have discussed about congruency of figures and congruency of triangle, and then let's discuss about the criteria rules of congruency of triangles. We have different types of criterion rules. like some of the properties of a congruency of a triangle. That is triplets property, triplets criterion, SAS criterion, ASA criterion, and RHS criterion. Let's start with the triplets criterion of a triangle. And two triangles, when we compare two triangles, the corresponding parts of or corresponding sides of the two triangles are equal to each other. Like if we take the corresponding sides of the triangle are equal, like triangle ABC and triangle PQR or any other two triangles we have taken, the corresponding sides are equal to each other, like triplets property using the side. So one of the triangle sides we have taken is correspondingly equal to the next triangle sides. So both the corresponding sides are equal. Then we call that triplets property. And then let's go to this SAS property. And how we compare two triangles. When we compare two triangles, like in that the two sides of that corresponding parts of triangle are equal. Like in one of the triangle, if we take the two sides the same at the same side at the same time, the corresponding parts of the another triangle sides are equal to each other, then we call the two sides are equal, and the corresponding angle is also equal in that two sides, and the another angle is equal to each other, and we call it SAS property. So that is two sides and one of the angle are equal, corresponding parts of the two triangles are equal, then we call them SAS property. And when we compare two triangles, so in that two corresponding angles are equal and one of the corresponding side is equal in the two triangles, and then we call it ASA property, angle side angle. And when we take RHS property, right angle hypotenuse side and one of the right angle, and two triangles, both the triangles are right angle triangles, that means each angle is 90 degrees, one of the angle is 90 degrees, and hypotenuse must be equal in both the triangles, and one of the adjacent side or opposite side is equal in that, any one of the side is equal, but it is corresponding to that another triangle, and then we call it RHS property. So up to now we have discussed about triplets, SAS, ASA and RHS properties. Let's recall. When we compare two triangles and all the three sides of one of the triangle is correspondingly equals to the three sides of other triangle, then we call it triplets property. And when we compare two triangles, two sides of the triangle is correspondingly equal to another triangle, then and one of the angle is equals to and one of the angle is correspondingly equal to another triangle, then we call it SAS property. The two sides and one of the angle correspondingly equal to each other, that is SAS property, AC, and two angles correspondingly equal to another triangle, the angles which are correspondingly equal to another triangle angles. So and one of the side is equal, that means two angles and one of the side is equal, correspondingly equal to each other, and RHS, one of the right angle, and the hypotenuse. What is the hypotenuse? Is that the hypotenuse is present in the both the triangles is also equal, and if you take either base or opposite side are equal, then if you take the base and base is equal to base or opposite side is equal to opposite side. In this manner, when we will compare the triangles. So let's try with some of the examples. For triplets property, when we see this picture, like we have one of the figure is formed like ABCD. In this, we can observe the two triangles in that is ADB and ADC. Two triangles are formed. Let's write triangle ADB, and triangle ADC. Two triangles are formed. This. So when we compare these two triangles, we have discussed earlier, the corresponding parts of the two triangles are equal. then we call them they're congruent to each other using the criterion rule of Triplets property, Triplets criterion. So let's write this, let's draw this two triangles separately, like in this manner. So this is triangle ADB and this is triangle ABC, and we can observe that it's given AB and AC are equal in this. So AB is 3.5, this is AC is also 3.5, this 2.5 BD, and DC is also 2.5, and one of the common ways, it's a common for both the triangles, that is AD, it is a common side for both the triangles, AD, and this is here BD and DC, corresponding parts. When we flip this one of the triangle, any one of the triangle, when we flip this and this both are congruent to each other, we can keep one on each other, one on another. So this is exactly equal, same size and same shape, and during the measurements they are equal. So then we call that congruency, and when the corresponding sides are equal to each other, and then we call them their congruence using the criterion rule of Triplets property. So let's write. So AB is equals to AC. Both are equal. We can know that this is 3.5 centimeters. This is given in centimeters, and PP is equals to DC is 2.5 centimeters. Now let's write AD is equals to AD. Both the sides are common, so both the sides are equal. So, and we observe that the three sides are equal, but only equals to another. So it is Triplets property using the Triplets criterion rule. These both are congruent to each other. Let's write triangle ABC is congruent to triangle ABC. Sorry, triangle ABD is congruent to ABD is congruent to triangle ABC. Let's write that same as it is. Triangle ABD is congruent to triangle ABC. Let's write here. So let's go to the next example, that is SAS property. Let's take another example. And this we can observe that this side is common for both the triangles. There are two triangles are common in that is triangle ABD and triangle ABC. Two triangles are common in that. Triangle ADB, triangle ADC, two triangles are common. Let's draw separately that. So triangle ADB, triangle ADB. Here one of the angles is common, and then this side here, triangle ADC, and the side is equal. And we can understand that what is the angle is formed here. Both the angles are equal. So angle A and angle A is divided into two parts. The two parts are equal. We can observe on them. So let's write these parts of this triangle. So angle A is equal to angle A. Both angles are equal. And AB is equal to AC. The corresponding parts are equal. And AD is a common side. AD is equal to AD. And then we say that these two triangles are congruent using the criterion of SAS. Using the criterion rule of SAS, these two triangles are congruent. Triangle ADB and triangle ADC are congruent to each other. So this is a congruency rule for SAS. Let's go to the next one, that is AC.